Hello and welcome to part 2 of Conjugate and Dividing Complex Numbers. We're going to, in this video, work with example 3 where we left off and talk about some radicals with negatives inside. So for this, we have 1 plus 3i over 2 plus 5i. So we're dividing, and we want to get a number in the denominator that does not have an imaginary number in it. So to do that, we have to work with conjugates. And if you remember, the conjugate, we're going to work with the denominator of a rational expression. And we're going to have our expression as 1, just written as a number over itself, an expression over itself. And it's the denominator of the rational expression you're working with, except the middle term, or the middlemost sign is going to be the opposite. So in this case it's a plus, so the opposite of that's going to be the minus. So we're really multiplying by the conjugate. And that can be represented as the following. On top, we're going to have to use the FOIL method, with 1 plus 3i as a quantity times quantity 2 minus 5i as the numerator of a rational expression, and as the denominator, you're going to have 2 plus 5i times the quantity 2 minus 5i. So, going through using the FOIL method, we'll have this 1. We're going to distribute it across everything in the second set of parentheses. We're going to have the 3i, and we're going to do the same, multiply by everything inside the parentheses. We're going to have the 2 on bottom. We're going to distribute it across everything in the second set. Then the 5i, doing the same, distributing it using the FOIL method. So to actually go through and do the multiplication, we have 1 times 2 plus 1 times a negative 5i. Then we have plus 3i times 2 plus 3i times negative 5i on top. And on bottom, we have 2 times 2 plus 2 times negative 5i. Then we have plus 5i times 2 plus 5i times negative 5i. Let's go through and simplify our multiplication. So 1 times 2 is 2. 1 times negative 5i is just negative 5i. Plus 3i times 2 is positive 6i. And then 3i times negative 5i gives you a negative 15i squared. All over, 2 times 2 is 4. Then 2 times negative 5i is a negative 10i. 5i times 2 is a positive 10i. Then 5i times negative 5i gives you a negative 25i squared. Let's continue on with our problem. So, on top we'll have 2, and then we simplify negative 5i plus 6i, we have just positive I. Now let's have negative 15, and let's replace the I squared with what it represents, or just negative 1, over 4. And if you look, the middle terms here, the negative 10i plus 10i gives you just 0, so those cancel out, minus 25. And in this case, the I squared, let's just replace it with a negative 1. So, simplifying this even further, okay, so let's just simplify what we have. So we'll have 2 plus I, and then negative times a negative is positive 15. And on bottom we have 4, and then a minus times a minus is a positive 25. So to solve our answer, 2 plus 15 is 17 plus I over 4 plus 25 is 29. So that is the solution to that rational expression using conjugates to divide. Now our final topic for this video will be when we have radicals, but there are perfect squares or numbers that can be broken down into perfect squares, and there's a negative number. So what we want to say for examples like this, the radical of negative 25 plus the radical of negative 36. So for this, you want to break it into saying that the radical of negative 25 is negative 1 times 25. Note that 25 is a perfect square, and it can come out of the radical as 5. And note that radical negative 1 will be left inside. Well, a negative 1 under a radical can just be replaced by I. So, over here, we have a radical of negative 36. You can think that it was the product of negative 1 times 36 under the radical. Note that 36 can come outside of the radical as 6, leaving negative 1 under the radical. So we're going to have 1i, or 6i. Combining these like terms of 5i plus 6i, you're going to be left with 11i as the solution to that problem. For number 2, a major difference is going to be that there are going to be numbers out from the radicals, and all we're going to do is take what we get from inside the radical and just multiply it by the outside number from the radical. So from here we can write 5, and then radical negative 16 can be thought of as negative 1 times 16. Note that we have 5 outside. The 16 can come out of the radical as a 4, since it is a perfect square, leaving radical 1 inside. So 4 times 5 is 20. Radical 1. Note that radical 1 can become just I. Okay, we have negative 2. And then inside the radical, negative 44, you can think of that as negative 1 times 144. And negative 2, think of 144 coming out of the radical as 12, because it is a perfect square, leaving negative 1 under the radical. So 2 times 12 is 24, radical negative 1. The final step is just to say that negative 1 in the radical is equivalent to just I, so we'll leave that with negative 24i. So now we have to combine like terms of 20i minus 24i. So when we do that subtraction, we're going to be left with negative 4i as our solution.